Hi there, in this video we're going to go through case number 2. So remember, in case number 1, if I take the previous example that we went through, if the coefficient of x is 1 and if the powers are all 1, that means use the definitions to solve the equation in question. However, if either the power, or the coefficient of x is not 1, that means use the hyperbolic identity first and the inverse definition for the hyperbolic function later to solve the equation in question. So that is case number 2. So remember, in case number 2, so remember in your equation, if the power or the coefficient of x is not 1, so if the power or if the coefficient of x is not 1, that means use the hyperbolic identity first, then the inverse hyperbolic definition, so the inverse hyperbolic definition, to solve the equation in question. So you'll see when we go through a couple of examples. So let's go through an example. Let me show you what I mean by this. So in example number 1, take a red pen, let's underline that. So in example number 1, we're going to be solving the equation. So in part A, we're going to be solving 3 hyperbolic sec to the power 2x plus 4 hyperbolic tan x plus 1 is equal to 0. So let me show you how this equation is going to be solved. So remember, if either the power or the coefficient of x is not 1, that means use the hyperbolic identity first, then perhaps the inverse hyperbolic definition later to solve the equation in question. So if you observe over here, we have a power of 2. So that to me means a case number 2, and we're going to be using the hyperbolic identity first. So in step number 1, we're going to be using the identity, in this case 1 minus hyperbolic tan squared x is equal to hyperbolic sec squared x. Now remember, it's a minus here, as a result of Osborne's rule. So in the previous video, I've said that whenever you have 2 signs or sine squared appearing in a trigonometric identity, you need to change the sign in front of that product to get the corresponding hyperbolic identity. So that minus arises from Osborne's rule. Have a look at that video on Osborne's rule. So in this case, if I replace the identity here, we're going to have 3 into 1 minus hyperbolic tan squared x plus 4 hyperbolic tan x plus 1 is equal to 0. And if I expand further, I'll have 3 minus 3 hyperbolic tan squared x plus 4 hyperbolic tan x plus 1 is equal to 0. Now I can simplify further, so if I add the like terms, I'll end up with minus 3 hyperbolic tan squared x plus 4 hyperbolic tan x. 3 plus 1 is 4, that is equal to 0. And when I solve equations, particularly quadratics, I don't like negative terms in front of my power 2 term. So in order to get rid of this negative sign, I'm going to multiply throughout by minus 1. So if I multiply by a minus, I'm going to end up with 3 hyperbolic tan squared minus 4 hyperbolic tan x minus 4 is equal to 0. Okay. So in this case we have a quadratic to solve. Okay. So let's solve this quadratic. So in order to make it easy for us, I'm going to let t equal hyperbolic tan x to give us 3t squared minus 4t minus 4, which is equal to 0. Okay, so I hope you can see that. And we can factorise this equation to give us 3t plus 2 and t minus 2, which is equal to 0. Okay, and as a result we've got two values of t, either 3t plus 2 is equal to 0, that means t will be minus 2 over 3. Okay, so that is our first value of t. Okay, or if I continue here, t minus 2 is equal to 0, that means t is equal to 2. Okay, so we've got two values of t over here. Okay, so these are the t values. So if I replace them in this equation here, okay, so let me continue on the reverse. So since t equals hyperbolic tan x, okay, so our first value of t that we found, so if we go back, is minus 2/3. So when t is minus 2/3, hyperbolic tan x is equal to minus 2/3. So I'm going to call that equation number 1. Okay, so that is one of the equations that we need to solve. Okay, and so we have another value of t, when t is equal to 2 in this case, we're going to have hyperbolic tan x is equal to 2. Okay, now this equation is not going to work, so I'm going to put a cross beside that, and the reason being is, okay, when we work out the inverse hyperbolic tan, so we're going to calculate the inverse in order to work out the x values, but when we work out the inverse hyperbolic tan, it won't work over here, because the inverse hyperbolic tan definition only works when the modulus of x is less than 1. Okay, so it's not going to work in this instant, but it will work in the first instant for equation number 1. Okay, so let's focus on equation number 1. So equation number 1 is hyperbolic tan x equals minus 2 over 3. So to work out x, that is the inverse hyperbolic tan of minus 2 over 3. Okay. Now, in order to solve this equation, you can use your calculator, and on your calculator there's a button called HYP. So if you press that, that should give you, so let's put that on, if you press it, that should give you a library of hyperbolic functions. So if you key in number 6, that is the number corresponding to the inverse hyperbolic tan function, or you can use the definition. Okay, so I've given you the definition in the previous video, so remember the definition. Let me write it here. Inverse hyperbolic tan of x has a definition 1 over 2 ln 1 plus x over 1 minus x. So remember, that definition only works when the modulus of x is less than 1. Okay, that is why this equation here doesn't work. Okay, so if we replace the x's here in our definitions by minus 2 over 3, you should get x is equal to 1 over 2 ln 1 over 5. Okay, so I'm going to leave my answer like that. Okay, however, you could use your calculator also and work that out using that HYP button. Okay, so that completes this example.